Hey class, Miss Anderson here. This brings us to our 5th lesson in trigonometry. And today's lesson is very important. We're going to learn about the unit circle and use it to evaluate trig functions of any angle. So yesterday we talked about this diagram, and we used this to help us remember that in quadrant 1, all of our trig functions are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. And we're going to take a closer look at different things in these quadrants today, and then what happens when we fall on the axes more specifically. The first thing we're going to learn about is the unit circle. The unit circle is a really important concept in trigonometry that we use a lot, and so we're going to have a great introduction to the unit circle today. A unit circle is a circle with a radius of 1, and we're going to use it to build the circular definitions for sine, cosine, and tangent. So I have a circle here, and I have it centered at the origin. I've marked out the radius, and so the radius brings us just to a general point on the circle, and that would just be like an XY point. It's in the first quadrant, so both X and Y would be positive. So to get to that point, you'd go over X, say it was 5, you'd go right 5, and then you'd go up 7, so that would be your Y coordinate if it was like 5, 7. So we're just going to assume it's just a general point in the first quadrant. So you go over X, up Y. And that makes us our right triangle. And then we can say our reference angle is right here, formed with the X-axis and that terminal side, or our radius. And then we can find our circular definitions. So our circular definitions come from this. We can derive them from this picture. And then we could say like sine of our angle is our opposite side over our hypotenuse, which will be y over r. Cosine of our angle is going to be x over r. And then tangent of our angle is going to be opposite over adjacent, or y over x. And then excuse me. So those are our circular definitions, and we would have our inverse, or not our inverse, our reciprocal functions. Then cosecant would be r over y, secant would be r over x, and cotangent would be x over y. We're going to focus on these main three, and in the unit circle, like I had mentioned, it has a radius of 1. So if your radius is equal to 1, then these would simplify. Sine of theta would be y over 1, which would just be the y coordinate around your unit circle. Cosine of theta would be x over 1, which is just going to be the x coordinate. And so sine is y and cosine is x, and tangent is y over x. Then tangent is the same thing as sine over cosine. And so a couple important things we can gather from that. If the radius is equal to 1, then the points around the circle would be right here where it crosses would be the point 1, 0. This would be the point 0, 1. This would be the point -1, 0. And then this one would be 0, -1. And then remember, we know the angle values for those points too. This would be 0 degrees. This one is 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees. And so because the cosine value is the x coordinate and the sine value corresponds to the y coordinate, we could easily find the sine or cosine of any of these angles using the points like 1, 0, 0, 1. And so the points along here are going to be cosine values and sine values. And then if we want the tangent value, we could take the y coordinate divided by the x coordinate. So let's do some examples with that. Those angles that fall, the terminal side lands on the x or y axis, are called quadrantal angles. So like 90, 180, 270, those are our quadrantal angles. So let's label this again real quick. We got a radius of 1. We're going to assume it's our unit circle, which means that this point here would be the point 1, 0, over 0, up 1, negative 1, 0, and 0, negative 1. And then if we want the drawing, we could put this right triangle here and remind us that that's our x and our y distance, so that our sine value is opposite over hypotenuse. So our sine value of our angle corresponds to our y value, and cosine is adjacent over hypotenuse. So cosine corresponds to our x because it's x over 1. And then tangent of our angle would be opposite over adjacent, or y over x. And then our angle measurements at the positive x-axis is 0. This would be 90, 180, 270, and then back to 360. So if we're looking for sine of 90 degrees, you're going to look up here. This is 90 degrees, and sine is my y coordinate. So sine of 90 would be equal to 1. If I wanted to find the cosine of 180 degrees, I would go to 180 degrees. And so I'm using the unit circle. Pick a point that is 1 away, which would be negative 1, 0. And cosine is the x value. So cosine of negative 180 is negative 1, or 180 is negative 1. Sine of 180, use 180, the y coordinate, so it'd be 0. 270 is down here. We'd have the point 0, negative 1, and we're looking at cosine. Cosine corresponds to the x coordinate, so cosine of 270 would be 0. Tangent of 0, so 0 degrees is the positive x-axis. Tangent is y over x, so 0 over 1, which would be 0. And then tangent of negative 90. So negative 90, you would go in the reverse direction. So this would be negative 90, negative 180, etc. So negative 190 would be down here. Again, tangent is y over x. So you would have negative 1 over 0. But you can't divide by 0, so tangent of negative 90 is actually undefined. Tangent would be undefined there. Okay. So those are our quadrantal angles, and we can use the unit circle to help us easily evaluate those functions quickly. Now we're going to look at another way to measure an angle, and this is radians. You've noticed that your calculator has 2 different modes, and we want it to be in degree mode. The other way to measure an angle is to use a radian. 1 radian is the measure of the central angle whose arc length is the same as the radius of the circle. And so if you have the center at the origin of the circle, the center, and you measure the distance to the outside is the radius. Now if you took the radius and you measured this distance along the outside of the circle, it would fit 1, 2, 3, 4, 5, 6. I didn't do this really well, but it's going to fit about 6.34 times around the circle. And the radius fits about 6.28 times, or it's actually exactly 2 pi. So there are 2 pi radians in a full 360 degrees. And the radius is the radian. So an arc length of 1 radian measurement is equal to the radius measurement. So because the radius fits around the circle, the 6.28 times, or 2 pi times, we get the conversion that 360 degrees is 2 pi radians. And the 180 degrees then is 1 pi radian, or about 3.414 radians in 180 degrees. So we're going to use this to help us convert between degrees and radians. The main points around the circle in radians that you should remember is that starting here is 0 radians, and then 90 degrees is equal to pi over 2 radians, since 180 degrees is equal to pi radians. So there are 3.14 approximately radians in half of a circle, and that's the same thing as 180 degrees. So 90 would be half of that, pi over 2 radians. And then if you count by pi over 2, so 1 pi over 2, 2 pi over 2, this would be 3 halves, or 3 pi over 2. So 270 degrees is 3 pi over 2 radians. And then 4 pi over 2 is 2 pi radians, or that would be equivalent to 360 degrees. 0 radians would be equivalent to 0 degrees. So those are our main ones. And then some of the other ones that we're going to look at is like the main radians for 30, 60, and 45. And we'll get to that. But these are the main 4. So we're cutting 2 pi into equal 4. So you're counting by halves. Pi over 2, pi, 3 pi over 2, 2 pi, going around. Since 1 pi radian is equal to 180 degrees, that's what we use to do the conversion. So if you're going from degrees to radians, you do the number of degrees times pi over 180. If you're going from radians or degrees, you do number of radians times pi 180 over pi. So think about it as like a unit conversion. So if I want to convert to radians here and I have degrees, I want the degrees to cancel and leave me with radian measures. So I'm going to put the 180 degrees in the bottom. So I'm going to multiply by pi over 180 on all of these. So to convert to radians, we multiply by pi over 180. So multiplying across would leave you with 45 pi over 180. Now 45 fits into 180 4 times. So this is the same as 1 pi over 4 if we simplify by 45. Or we just write that as pi over 4. So 45 degrees is pi over 4. And that makes sense if you think about it on your unit circle, because 45 degrees is halfway between 90, 0 and 90. And so halfway between 0 and pi over 2 would be pi over 4. So that'd be 45 degrees. Convert to 30 to radians times by pi over 180. Be 30 pi over 180, which is 3 pi over 18. If we divide by 10, then both of those are divisible by 3, so pi over 6. So reducing the whole number as we would reduce fractions. So 30 degrees is the same thing as pi over 6. 60 degrees multiply by pi over 180. So that would be 60 pi over 180, or 6 over 18, which is pi over 3. 6 goes into 18 3 times. So I think those make sense too if you think about it carefully, because if you look at the 180 degrees is right here, that's pi. So if we were to split this into 60-degree pieces, there are going to be 3 equal pieces. So you'd have like a 60 degrees right here and right here. So we would want to split that into, this would be pi over 3, then 2 pi over 3, then 3 pi over 3, which would make our pi. So that's why 60 degrees is pi over 3. It's equal thirds. And then 30 degrees is half of 60. And so that splits it into 1, 2, 3, 4, 5, 6 pieces. So each 30 degrees is pi over 6, taking that pi into 6. So those are where those fractional pieces come from, splitting the 180 into the equal angle measurements. 120 degrees into radians, put it over 1, multiply by pi over 180, which would be 12 pi over 18, and then both 12 and 18 are divisible by 6, so 2 pi over 3. be 120 degrees. To go backwards, you want to convert to degrees. You're going to multiply by 180 over pi. So 5 pi over 3 times 180 over pi is going to cancel pi. And then you can either multiply 5 times 180 on top, which would be 900. And then we have 3 times 1, which is 3. And then divide from there, which would be 300 degrees. Or you can try to simplify first. If you know that like 18 over 3 is 6, then 180 divided by 3 would be 60. And then 5 times 6 would be 300. Or 5 times 60 would be 300. So you can simplify a little bit before you multiply, or you can multiply and then simplify. So 3 pi over 4, it's ending. Notice that this one was over 3, so it's over 3, so it is a factor of 60, because pi over 3 is 60 degrees. This one ends in 4, so it should be a multiple of 45 degrees. 345 degrees to be exact. So 345 degrees be 45, 90, should be 135. Let's multiply it out. So times by 180 over pi cancels the pi. Then 3 times 180 on top is 540 over 4. 540 divided by 4 is going to be 135. And so I looked at the fact that it was pi over 4, which I know is 45 degrees, and then there was 3 of them. So that's how I could find 135 another way. You can have negative radians just like you can have negative degrees. A positive degree goes this way, where a negative degree goes this way. Same with radians. So you can count a negative radians degree would go this way. Remember, pi over 6 is 30 degrees, and we have 5 of them. So 5 times 30 would be 150. This should be negative 150 degrees. We can find that by taking and multiplying it by 180 over pi. So get rid of the pi's. 5 times 180 on top is 900. Negative 900 divided by 6. Be negative 150, which is what I got using the fact that I knew that pi over 6 was 30 degrees. So it's really helpful to know these main 3. 45 is pi over 4, because it's splitting half of 90. 30 is pi over 6, and 60 is pi over 3, because 180 degrees is 1 full pi radian. So that's where we get these fractions from. And if you know these, then converting the other ones is going to be much easier too. We can find the sine, cosine, tangent, any of the 3 or any of the 6 with radians as well. So if we were to consider pi over 4, remember this is pi over 2, this would be 0. So pi over 4 would be exactly in the middle here, which means that it would be 45 degrees if you wanted to convert that. And then we could drop down that would be our reference angle. We could make our right triangle. Since it's 45 degrees, our triangle ratio would be 1, 1, square root of 2. And then we could find the sine of pi over 4 by using this triangle. So it'd be 1 over the square root of 2, which you would rationalize to be square root of 2 over 2. Pi over 3, this is pi over 2, 0. So pi over 3 is going to be, if you think about 1/2 and 1/3, 1/3 is just a little bit smaller, or actually it's closer. It's 1/3, 1/4. It's a little bit bigger than the 4th. So pi over 3 would be right here. Or think pi over 3 is the same thing. 180 divided into thirds is going to give you 60. So pi over 3 is the same thing as 60 degrees. So if you want to find secant of pi over 3, you can use the reference angle of 60 degrees. We're in the first quadrant, so this would be my 30 degrees. Across from that would be 1. Across from 60, square root of 3 and 2. And then secant is the reciprocal of cosine, so it'd be hypotenuse over adjacent. Hypotenuse over adjacent would be 2 over 1, so my answer for secant of pi over 3 would be 2. Cosine of pi over 6, this is pi over 2, so pi over 6 is in the first quadrant again. 180 split into equals 6 would be 30 degrees, so pi over 6 is going to be like 30 degrees here, which is going to give you a 30, 60, 90 triangle. Across from the 30 is 1, across from the 60 is square root of 3, the hypotenuse is 2. Cosine is adjacent over hypotenuse, so the cosine of pi over 6 would be square root of 3 over 2. Square root of 3 over 2. Now you could check these answers in your calculator, but you would have to make sure that you switch back to radian mode. And then you would do cosine of pi, cosine of pi divided by 6. It's going to be rational, so you'd have to double check that the square root of 3 divided by 2 is the same decimal as that, which it is. But you would have to change your calculator to radians in order to check that. I like to leave mine in degrees. All right, got a little long, but thanks for watching.